Alright, in this problem, number 59 in textbook section 11.7, it's about a rocket ship that has a backup system. So it has an independent backup system from its communication networks. So the probability that, now there's two backup systems, the probability that either system functions satisfactorily, meaning that it works, is 98.5%, so 0.985. So right from there, that means the probability that it doesn't work is going to be the complement of that. So 1 minus 0.985, which would be 0.015. Alright, so there's a 98.5% chance one of the backup systems works, so there's a 1.5% chance that one of the backup systems doesn't work. So in part A it says, what's the probability that during a given flight both systems function satisfactorily? So in the question it says they're independent of each other, which means like they're separate systems. One could fail regardless of how the other one does. So that means we can multiply these probabilities together. So the probability that these both work is going to be, well, there's a 98.5% chance the first one works times 98.5% chance the other one works. So it's going to be that 0.985 squared. So probably somewhere in the 90 percentile range. You have to type that in the calculator to find out. Okay, so that's part A. Now for part B, what's the probability that both systems fail? So it's going to be a similar setup, but now we're going to use the complement. So both fail. Now we're not going to take our previous answer and subtract it from 1 because that's the probability they both work. The opposite of that is not they both fail. I mean, one of them could also work. So what we have to do is find the probability that one of them would fail, which is 0.015, and then times the probability the other one fails, 0.015, and then multiply them together. Okay? And that would be part B, not part A. Okay, so now for part C, it asks, what's the probability at least one of them functions satisfactorily, meaning at least one of them works. Alright, so C, at least one works. So what we have here, so there's a 100% chance that out of these two systems, none of them work, or one of them works, or both of them work. So to find the probability at least one of them work, you could do this. You could find the probability one of them works plus the probability of two of them works. And here's how that would look. It would be the probability that one of them works is either the first one works and the second one fails, or the first one fails and the second one works. This right here would be the probability just one of them works. And then you would have to add it to this, the probability that both work, which would be 0.985 squared, which we found earlier. Okay? Or another way you could do it is you can solve for this, which is the probability at least one of them works, by subtracting the probability none of them works on both sides. So if you find the probability that none of them works, which was 0.015 squared, we found that earlier, that's the probability both of them don't work, both of them fail. We could subtract that from 100%, and this would give us the same answer as this. They would both equal the same number, because they're just two different ways to find the same thing. Alright, so this here is saying, well, there's a 100% chance none of them, they both fail, or at least one of them works. So if you subtract the probability that they both fail from 100%, that's the probability at least one of them works. Or the probability that at least one of them works is only two cases. One works or both works. So you find the probability that one of them works, either the first or the second one, and then add that to the probability of both of them working. So two different ways to do it. Both of these should give you the same answer.